We've learned about objects, we've learned about arrays, but this lecture is going to be epic. But let me start off by saying that all JavaScript engines use the concepts discussed in this lecture as a way to optimize code. And as you can see from the heading, this is shapes. But different engines call shape different things, so when you start Googling this, you may come across different terminology. Some people refer to these as hidden classes, but this is confusing because we've got JavaScript classes. V8 calls them maps, but this is also confusing because remember we used that map iteration. Others call them types. JavaScript core calls them structures. But SpiderMonkey calls them shapes. And just to avoid confusion with other terminology, I've decided to call them shapes as well. But anyway, I digress. We now know how objects are defined in JavaScript. We've been working with them. But in this lecture, I want to dive deeper. I want to discuss how JavaScript engines work with objects. Looking at what we've done so far with objects, you've probably already guessed that accessing properties is by far the most common task. What do I mean? Well, when we have an object, let's just define a user object here, the first name and last name, it's going to be very common for us to query those values. For example, user.firstname, we're asking the engine to go and fetch us the first name of this user. And because of this, it's crucial for JavaScript to make this process as quick as possible. Okay, you get it. So what is a shape? Well, let me say this. It's common to have multiple objects with the same property names or keys. For example, let's create a dog and snake object. For example, let's say we had a dog object and it's got two keys, two names, type and age. Now we create a snake object and it's also got type and age. It's intuitive that these two have the same shape. Those objects have the same keys, and that's all we mean by shapes. Shapes are just objects that have the same look and feel. But let's dig deeper to understand what JavaScript does with objects. So let's create an object with properties x and y, each with a value of 10 and 20. When we create these objects, we know the JavaScript object model is implemented. Remember we looked at the JavaScript object model? And all I mean by this is that each object uses the dictionary data structure we discussed earlier. It contains the keys as strings. The keys here are x and y, and those keys point to their respective property attributes. Now, when we access the property x on that object, i.e. we actually type into our code obj.x, or in the case of our user object, we type user.name, what's going to happen? Well, the JavaScript engine is going to look in the JS object for the key, for that x. And then it's going to load the corresponding property attributes. And then finally, once it's done that, it's going to return the value. You see the value there in square brackets? It's going to return that. In the case of x, it's going to return 10. But these property attributes, where are they stored in memory? Let me ask you another question. Should we store these property attributes as part of that JS object? Before you answer that, let me just say, what if we end up creating thousands of objects that have a similar structure, i.e. that have the same shape? I would argue it would be very wasteful to store the full dictionary, which contains property names and associated attributes on each JS object. Why? Because this is going to result in a whole bunch of duplication and unnecessary memory usage. Cool, so we know it wouldn't be efficient to go and duplicate these property attributes for every single object that has the same shape. So then what does the JavaScript engine do? Well, it stores a shape of the object, and it does this separately to the actual object itself. And this shape will store all property names and attributes except for their values. Instead of storing the value property, the shape has to store the offset value that references the JS object so that the engine knows where to find the value. And this means that every JavaScript object that has the same shape will point to exactly this one instance, this one shape instance. No duplication and no memory leakage. And because each JavaScript object is unique, each item is going to have different values. That just means that that object only has to store their unique values. Let me show you what I mean. So let's get our object with x and y. Now, instead of that object storing the keys, it's only going to have its values because those values are unique to it. So it's only going to store the values 10 and 20. And that object is going to be pointing to a shape. And that shape is what's going to be storing the keys and the associated offsets. Does that make sense? So we know when you're looking at the shape, the X points to property attributes with an offset of 0. And that's why the JavaScript engine is going to know that X has a value of 10. Are you confused yet? Good. It's part of the journey. It's part of the journey. Perhaps this example will even be more clear once you have multiple objects. So let me show you that now. We had an object, obj, that just had X and Y. Now let's create obj1 and obj2. So we got two objects now, but with different values. And this is probably going to make sense to you now, because now we got two objects and they both store their unique values, but they both point to the same shape because they both have the same shape. How awesome is this? And you can already see now that instead of storing that information in both objects, those property attributes, it's only stored in one shape. Just remember, even if you're getting confused now, just remember this. No matter how many objects there are, hundreds, thousands, millions or billions, as long as they have the same shape, we only have to store the shape and property information once. But so far, we've only seen examples where we have an object and a predefined structure. We've never had to add properties to it. Which of course begs the question, what happens when we add properties to an object that has already been created? What happens to the shape? Well, this is where transition chains and trees come into the picture. Let's create a user object. And initially, let's just set it out so it's empty. It's got no properties. What is its shape? Well, its shape is also empty. So at this point in time, the user object is pointing to an empty shape. Simple, right? But now let's add a property called name to this object with a value John. As soon as you do this, a new shape is going to be created. The JavaScript engine now transitions to this new shape that contains the property name. The user object has a value of John as its first offset. At this point in time, it's actually the only offset. But let's keep going. Let's now add a property called age to the user object and give it a value of 38. You guessed it, another shape is created. The JavaScript engine again transitions to this new shape that now contains both name and age. The property attributes attached to that age, it tells us that the value for age can be found at the offset 1 position of our user object, which makes sense. And just as a side note, an FYI, the order in which properties are added to the object does impact the resultant shape. For example, we defined name and then age, but that's going to result in a different shape than if we had first assigned age 38 and then named John. Makes sense, it's just going to shuffle around our shapes. In fact, another way to represent this image that you're currently looking at is the following. As you can see, we don't need to store the full table of property attributes for each shape. Instead, every shape only needs to know about the new property it introduces. For example, in this case, we don't have to store the information about name in the last shape, because it can be found earlier in the chain. And to make this work, every shape links back to its previous shape. And this is why it's called a transition chain. It's like a chain. It's like one big chain with a lot of links, and all these shapes have links to each other going back. Now, in our case, what if we want to access the name property in our user object, which we know is John? When we write user.name, the JavaScript engine is going to look up the property name by first approaching the age shape. Why? Because that's the furthest down on the chain. It's not going to find it there, so the engine's going to keep having to walk up the transition chain until it finds the shape that introduced the name property. Make sense? Whew, okay. Now we're almost done, but I want to get a little bit more complicated. What happens if you have two objects that are first empty and then you place different properties on each of them? Well, remember how I said transition chains and transition trees? This is where the trees come into it. Because in this case, we're going to have to branch out. Instead of having a transition chain, we're going to have a transition tree. Let me show you what I mean. Let's create a user1 object. First it's empty, and then we place a property name onto it. We're going to end up with a JS object called user1 that contains a single value, in this case John. And it's also going to result in how many shapes? In 2 shapes, that's right, the empty shape and the shape with only a property called name. Okay, and let's create user2. User2 is also going to start with an empty object, but then let's add a different property called age. What is the result of all this? Well, we're going to have 2 objects, but they're going to be 3 shapes. There's going to be 2 shape chains, one related to user1 and another related to user2. But let me ask you this now. Does this mean there's always going to be an empty shape associated with every object? No, not at all. Let me show you another example. Have a look here. Let's say we create user1, starts off as empty, and he's got a name of John. We know in this instance we're going to have a JS object with value John that points to an empty shape that then transitions to a new shape with a property name of name. We know this. But let's say we create a second user, but this time we immediately create a property called name to it. In this case, we've created an object that immediately has the name property. And this means the JavaScript engine has not had to start from an empty object and transition to a new one. It's immediately just gone to the end result. And I'm going to make a very good point here. This is why object literals can be very good. Because this optimization that we've just seen, it shortens the transition chain and makes it more efficient to construct objects from literals. Now I want to get just a little bit more complicated. Just bear with me. Hold on tight. Don't stop now. You're almost done. This is very, very useful information. Very interesting. Let's create a user object with 3 properties now. Name, age, and bald. Let's just say if he's bald or not. As we learned before, this creates an object with how many shapes? With 4 shapes in memory. That's right. And now to access the property name on that object, the JavaScript engine needs to follow the linked list. It's going to have to start with the shape at the very bottom. And then it's going to have to work its way up to the shape that introduced name, which is way at the top. And as I'm sure you've already guessed, this is going to be really slow if we do this more often, especially when the objects have a lot of properties. So to speed up searching for properties, the JavaScript engine adds a shape table data structure. And the shape table is a dictionary mapping property keys to the respective shapes that introduce the given property. Here is the shape table and what it looks like. In effect, it's another kind of dictionary that shortens this whole process. For example, you can see on the screen that the shape table will tell the JavaScript engine where to find these property values, in which shape to find these property values. So when we search for the name, it still starts in the shape, in the later shape, but that later shape points to a shape table. And there the JavaScript engine knows to look in which shape to find that name property. It's making sense, right? What? I cannot believe it. Are you serious? Now we've got another shape table. Oh, I thought the whole reason for shapes was to avoid the whole dictionary lookup. Now we've got another one? I don't get it. I'm just going to give up. No, don't give up. I know the answer. And the reason is that the shape table and these shapes are a means to an end. And that is to enable inline caches. Inline caches are the true secret behind JavaScript's runtime environment. It makes JavaScript so fast. And I don't want to go into too much detail about inline caches because that's a whole topic in and of itself. But I hope I've given you enough flavor and enough knowledge so you can dig deeper into this topic if this is what interests you. But we're not quite done with this lecture because A, I want to show you what a shape table looks like, and B, I just want to introduce you a bit more to the concept of an inline cache and what it actually means, but at very, very high level. So just get a coffee. We've only got 1 minute left or 2 minutes left max of this lecture. So hang in there. Let's get back into it. And I don't want to get into inline caches. We know that it's another whole topic in and of itself, but just at a very high level, this is how I like to think of it. Say we create a function called test that takes in a user object and we just console log the user's name out. When you execute the function for the first time, the inline cache will look up the property name and find that value is stored at offset 0, right? Because we know the user1 object has the name John, in this case at offset 0. When you execute that function, it's going to find that offset And the inline cache will memorize the shape and the offset at which that property was found. So when you look at the JS function test, it's going to store that offset 0 in that function call. And what this means is that if the JavaScript engine sees objects with the shape that the inline cache recorded before, it no longer needs to reach out to the property information at all. Instead, the expensive property information lookup can be skipped entirely. And this is significantly faster than looking up the property each time. Let me show you what I mean. So see how we've set up the test function. We've called it on user 1. And the inline cache has stored the offset 0 in the function itself. Now, when we call it on user 2, what do you think is going to happen? Well, in this case, the inline cache is going to recognize that it's got the same shape. And instead of having to look up the property attributes and go to the shape tables, etc., it knows it's at offset 0. So all it does is it takes that inline cache of 0 and it returns the value Wally from that object. Cool, right? But anyway, that's a very high level of inline caches. You don't have to really understand it too much in depth now, but if you do want to dig deeper, I hope I've given you enough of a flavor. Oh, this has been a long lecture, so thanks for bearing with me. Well done if you've got this far. I just want to recap quickly. We've learned how JavaScript engines store objects and arrays, and how shapes and inline caches help to optimize operations on these objects. And based on this knowledge, what can we take away from it? Well, if there's one thing we can take away from this that's practical, we must just initialize our objects in the same way, so they don't end up having different shapes. For example, if you want to create a user object, don't create one with a property of name, another one with fname, another one of first name, another one of first and then a capital N for name. Those are all going to have different shapes, and it's going to make things more complicated and slow in the background. Rather be consistent in how you initialize your objects. Cool, I hope this has been very informative to you. I had a lot of fun putting it together. It was quite a complicated topic and not many people know about it. So yeah, enjoy it and let's move on. Let's get into some more JavaScript. See you soon.